Hello and welcome. Uh, Today I have a new project that I'd like to work on, and basically I did a search today for running Huggingface models on macOS, and I found this vlogger's video, and it seems that very recently PyTorch has come out with a new version for M1 Macs, and I've recently purchased an M1 Mac. So I bought the Mac Mini, and I've been setting it up and getting it ready for development. And I thought, well, it's about time that I start doing some work on PyTorch, and specifically with Hugging Face models, getting some of them running, see how well they perform. So if I scroll down here a bit, you should be able to find this if you just search for new GPU acceleration for PyTorch on M1 Macs. Should be the first thing that pops up. If you come down here, you'll see that there's a notebook down here, and if you click on this, that will open. And I think this is it here. And so, actually, before we start this, I went in and I tried to load the correct version of PyTorch, and it just didn't work. And so there is where is it here? Oh, I thought I had it up here. Oh, here it is. And so if you go over to the PyTorch website, they have this little widget here, and you can click on the appropriate boxes here, and it will give you this line down here. And supposedly copy this, and then it will install. Well, it doesn't work. And I guess the main reason it doesn't work is because this is for Intel, not for the ARM processor that is on an M1 Mac. So with this in mind, let's go over here. This is that notebook that looks like it's James Callum has put together. And the first thing it tells you to do is check your platform. Make sure that you're running 12.4 for your OS and that you're on the ARM64 platform. And if you're not on 12.4, you can go up to the Apple menu here and upgrade software, and you can get onto 12.4. If you're on an M1 Mac, that's going to work for you. And so let's try this out here and check. I'm going to come over here, and I am going to do what am I going to do here? I'm going to do Python, and then I'm going to go in here and do an import platform, and then run this platform.mac under ver, and you'll see I'm at 12.4, and I am indeed on an ARM64 platform. And we can quit from here. Remember to put the parentheses in, and let's go back here. All right, so there's also this, oh, I forgot, we can run this platform.platform here. Let's do this again, Python, import, and then platform.platform. There we go. It more or less tells you the same thing, but why not see this at least once? My guess is that you'll need to do this again another time because we're in a new world here with this ARM64. Alright, so the next thing here is we're going to be doing things inside conda. And because we're going to be working inside of conda, we have to do things a little bit differently for ARM64. First of all, we're going to need this environment variable set. If I go back here and I do an echo $conda under subdir, we're going to see osx-arm64. Now, I put this in my .zshrc file all the way at the end here, and so automatically whenever I open up a shell, I'm going to have that environment variable set for me. Now, in this article, after we set this, we run this conda create command, -n, and that's either ML or M1. I think it's ML here. Python equals 3.9. So we're going to create a virtual environment with the name of ML, I guess for machine learning. We're going to use the latest Python, which is 3.9. And we're going to grab that from the conda forge channel. Now, when I set up miniconda on my system, I set up conda forge or mini forge, and so there are two ways to set up miniconda. And if you have an M1, you should use mini forge. So just Google install miniforge on an M1 and it should come up with the procedure for doing that. So once you create your environment, you have to activate it. So that's conda activate ML. In my case, I thought it said M1 because of the M1 chip, and so that's how I set it up. And that's doesn't matter. You can call it ML or M1. Doesn't matter as long as you know what it is. So you can see here that on my prompt here, once I switch over to it, M1 shows up as my active environment in my prompt. This is power level 10K, this prompt system. Excuse me, a little bit of a frog in my throat today. Alright, so once this is set up, and you've activated it, then we want to run this statement here, conda env config var set conda under subdir equal osx-arm64. I'm not exactly sure what this is changing. If this is a way to get an environment variable that only shows up when you are in that particular environment, virtual environment. I think that's what it's doing, but I'm not sure. I'm not the last word in virtual environments or how conda works. I know enough about it so I can generally get it to work the way I want it to, but I didn't write it. I'm not that much of an expert in it. I'm guessing that that's what's happening here, that this is being stored someplace, but I have it also set in my .zshrc file, so I know it's going to get set. Now, what's the purpose of this? This is obviously for conda, and what it is saying is that we know that conda is smart enough to figure out that we are on a Mac, that we're running macOS. But it's not smart enough to know what processor is running. Is it Intel or is it ARM64? Well, this is a way of saying that it's ARM64, and then when we want to install modules, we don't want to install the ones that were compiled for Intel. We want to install the ones that were compiled for ARM64, so they'll run natively, they'll be faster, and won't cause as many problems. So this is something new for conda. Certainly never saw this before when I was working in Linux. And even for people who've been working with Macs for a long time, this is something new. So don't forget to do this. And then we want to run this statement down here, this pip install. And I know this is crazy because we installed conda, we installed we got the environment variable set for it, etc., etc. And now, when we're installing the module, we're not using conda to install it, we're using pip to install it. I don't know if it uses that environment. If pip is able to use that same environment variable, I doubt it. But what we're doing here is we're giving it this URL here to the nightly CPU wheels for PyTorch. And so when this runs, it says down here during the download, you should be able to see something like downloading torch, blah, 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 arm64.wheel. And yes, indeed, I did see this for each one of these guys that was being downloaded. Torch Vision, and Torch Audio all had this arm64.wheel at the end of it. So that way I know that the wheels that were downloaded were correct. If you don't know what a wheel is, it is a compiled module. So you can either download the module and then compile it yourself, or you can just grab a compiled module. And it's usually safer to get the compiled module because then you don't have to worry about what compiler you're running, which can cause problems. Alright, and once this is done, pip install transformers datasets. And of course this fails. And why does it fail? It failed because I didn't have Rust on my system. This compiles using Rust. And so it gives a way to put this on, install Rust using curl. And I didn't do it this way. I used a homebrew instead. I did brew install Rust. And that worked fine. And then I ran this pip install transformers datasets again, and everything worked fine. So now we can run this import torch and all of this stuff in Python as we saw before, or we can run this in a Jupyter notebook. And so what I did here, here's that brew install Rust, pip install transformers datasets. Then I just checked the version here, rustc -- version, to see if I had a new enough version. And if I do it here, you'll see that I have 1.59.0. And so this is actually a much newer version. This is version 1.2. It's a very old version of Rust. And I didn't see any benefit of having this old version, so I put the newer one on. And I doubt that's even the newest version, but it's not as old as this one here. So then I went in and I thought, let me install Jupyter Lab. And it didn't work correctly. It did, but then I started thinking, well, what if there's an Intel version of this? Then it's going to run very slowly. It's going to be going through Rosetta. So I did an uninstall of Jupyter down here. And then I tried to install it with conda. And it didn't work that well. And I kept trying different ways, installed it, uninstalled it, and finally I got Jupyter loaded through conda, but Jupyter Lab was telling me that it was not installed. It installed all the others through conda, which means that it if available, was going to grab the ARM64 version. And so I went and looked on Stack Overflow to find out why Jupyter Lab was not showing up there. And it told me to do this thing here with the path, which I did, and I made sure that I added it to my .cshrc, and didn't fix it. Was not the problem. But this is not a bad thing to have this in here. This will check .local/bin for programs. It's not going to hurt anything. I left it in there. And then what I did was, because I couldn't find it in conda in that channel, I just did a pip install of Jupyter Lab, and then this installed 3.4.3, and I double checked here all of these versions, and I still had all of the same versions from before. So installing Jupyter Lab did not mess up any of this other stuff here. And you need some of this other stuff, like the IPy widgets, things of that sort, to make sure that when you run your notebooks, that you have all of the widgets and things that you need for it. So it looks to me as though this is set up correctly now. So what we can do here is we can do a Jupyter, delete that, lab, like this. And this should open up a notebook, and I wonder if this is using the right kernel here. It's using this IPy kernel. I don't know, this doesn't look correct. I think that we need to make sure that we're using the kernel from the virtual environment. Now, I don't want to mess with this now. This is something that can be figured out at a later time. I'm going to shut down this Jupyter Lab and close this up, because we really don't need it now. What we can do instead is over here, we're in the correct guy here, we can run Python here. And in fact, I'm going to close this one up. We don't need this history anymore. And we can start running this stuff from here. Now, I could run this directly in that other directly in that other notebook, but I didn't write that notebook. And my understanding is that there may be stuff hidden in other people's notebooks that you don't know about. I'm not exactly sure how to do it. It's not something that interests me particularly. So I prefer to just do this myself. So I'm just looking through here. I'm doing the up arrow and making sure that all three of these lines ran, because I copied them and ran them all at once here. All right, so you can see here that when he ran this on his, he had a problem here because he didn't have the IP widgets installed. Right, so the progress indicator wasn't found. So that's a problem he's having, and it doesn't look as though he's addressed it at all. Let's see what this is. All right, torch.has MPS. I don't know what that is. I'm not sure what an MPS device is. So let's put Python here. Is an MPS device. Multi-process service. Well, we can get this to be read for us here. Now forget it. I will do that now. Excuse me. The multi-process service is an alternative binary compatible implementation of the CUDA application programming interface. So anything you can run in CUDA, you should be able to run in something that has an MPS, a multi-process service. And so if we look back here, we imported Torch, and Torch must have an MPS. Oh, maybe not. Maybe Torch doesn't have it. Maybe it's on the M1 chip. We can check that. Let's see. SOC MPS. Yeah, hyphen. Well, it looks as though I'm not going to find this easily. So I don't know where the MPS resides. Is it software or is it hardware? It doesn't look as though we're going to get that answer easily from Google, but we know we have one because it comes back. Torch tells us that it's true. So it tells us here that this is the new MPS-enabled Torch. So we're going to try to load this now. I don't know how long this is going to take. Alright, that wasn't bad. And let's see, track is with a C. Alright, so it's a data set with a dictionary. So I guess data set is a tuple that contains a dictionary. Is that right? I'm not sure. So anyway, there are 1,000 rows in this. We can look at track 0 here. This is the first item. So this looks as though each one of these items in here is a dictionary with 3 different items in it. So we have label coarse, label fine, and each of those is set to 0, and text is set to this question here. All right. All right, so we're going to need to create a tokenizer. And then create a model. We're going to download this model here. So I'm getting close to 100 megabits a second on this. That's not so bad. So you're getting 12 megabytes. That's fairly close to 100 megabits, which is the upper end of what's the service that I've contracted for. So I guess this is being grabbed from Huggingface, and that's fine. What does it say here? this is expected if you are initializing BERT model from the checkpoint of a model trained on another task or with another architecture. For example, initializing a BERT for sequence classification model from a BERT for pre-training model. So I don't know what this model was originally. I just know that this is the one we were told to go grab. So it's very likely that this was trained for some other purpose, and now we're grabbing it for our purpose. A BERT for sequence classification model, not a BERT for pre-training model. All right, so what is this? A pre-training model, I guess, would be something that we were going to use for transfer learning. We were going to have a whole big data set and then tune this model for our particular purposes. Instead, what we're doing is we're grabbing it as a classification model, which would mean that this is something we expect was about as good as it's going to get, and we're just going to use it this way. All right, so now we test inference time using a batch size of 64 on the CPU. So we're going to grab 64 of these guys. It looks like we're just grabbing the text from it. I keep doing this. All right. And we're going to stick them in this text variable. Now we're going to tokenize them. There we go. Command V rather than trying to right click on it, which doesn't seem to work. All right. And now we're going to do some of this. No, we can't do this. This is magic for Jupyter. This is not going to work. But my system, I think it will time it anyway. Time a process in Python. Not sure. Let me see. I'm just going to count this out. Let me see if this works. I don't think it's going to work unless I'm in a Jupyter notebook. Yeah, it's not going to do that. Let's see what this tells us. Well, whatever that was, it happened so quickly that it was less than a second. Well, yeah, this says 547 milliseconds. That's half a second. Yeah, I'm not sure how we can time this. I think I have to wrap it. I think I have to import time, and then I have to wrap it inside this guy here. But I don't want to do that during this video. It's going to take me some time to figure that out, and I don't want to bore you in the process. I'm probably already boring you. All right, so let's see next here. I'm going to grab 256 of these. And I keep doing this, and paste is all the way down here. Alright, let's try not to do it again. Do it that way. We're specifying here that we're going to use the CPU. Alright, and now so this takes 3.69 seconds. 1, 2, 3. And it's done. Alright, so yeah, I have to figure out how to do that timing thing. But actually, what I'm going to be doing is, once I'm off this, making this video, I'm going to go into Jupyter Lab and figure out how to get that working properly. And then I'll just use this time it magic here. And that's what they call that. They call that magic, Jupyter magic or something like that. All right, so now we're going to change the device to MPS. And I guess this means it's going to use it's going to make a plan to use the CPU, the GPU, and the NPU, the neural processing unit. I'm not sure how this works. It seems to be something of a mystery, exactly what goes on under the covers. Uh, I can show you something. Let's see here. Uh, ASI top. No, I don't want to do that. I do not want to do that on camera. Close that up. Open it back up. And so now we may be able to get a glimpse at what goes on. I'm going to move the model to the device. And now we're going to move the tokens to the device. All right. Now we're going to check the device. And now we're going to run this again here. And this should take just under 2 seconds. All right, and let's take a look over here. We're going to take a look at the E and the P cores on the CPU. We're going to look at the GPU over here, and actually we can watch them up here. One, 2, 3 here, and here's the ANE, the neural engine, and we'll see if that gets used at all. 1, 2, 3, 4. Well, I thought this was supposed to be faster. It seems to me this took longer. And that doesn't really surprise me because I've been told that things can run faster on the CPU sometimes. Let's try it again. 1, 2. Well, that time it only took 2 seconds or so. But I guess everything was loaded up. Yeah, the neural engine was not used according to this. And well, it goes on. We're going to try some different batch sizes here, and so on here. Now, all right, let's do this anyway. I'll do this quickly. And the reason I'm doing this quickly here is because see, I'm running all these lines at once. These should happen very fast. It should take just a fraction of a second. 78 milliseconds. Yeah, really fast that happened. We're going to come back here. We're going to set this device again to MPS. And then we're going to run this again. One, 2, 3. All right, that takes longer. Yeah, well, look, this says 189. I got 3 times as long, and that looks about the same. So I don't know why this takes longer to run on the MPS than it does on the CPU. I suppose that the CPU is more direct. Since everything has to go through the CPU to get to the MPS, it's another device or virtual device that has to be loaded up, and that takes time. My guess is that for very small batches, things are going to run faster on the CPU, but if the batches are large enough, they'll probably run faster on the MPS. All right, so here it's doing that, importing the time. Right, this is no longer Jupyter magic. This is plain old-fashioned Python. And so we're going to do a CPU test here, and then we're going to do a GPU test here. and we'll be able to compare the two. And as you can see, we're still not using the neural engine. Now this is a much larger data set, so it's taking quite a bit longer. And we're seeing the memory usage. So up here we're seeing the percentage of cores, and down here we're seeing the percentage of memory used by, or not the percentage of memory, but the actual amount of memory that's being grabbed by the different kinds of cores and by the GPU. Down here we're showing how much power is being used. And you know, the M1 chip is pretty amazing at how little power it draws. I mean, we're drawing less than 15 watts. At our peaks we're getting 13.46 watts. So that's pretty amazing. I have a K80 that is 300 watts. NVIDIA Tesla K80. Yeah, so, but I mean, it's much more powerful, but it really sucks power also. So what's going on here? Because we've gone into super low power. So it looks as though the MPS is using far less power than the CPU. That's unexpected. Look, we're down to 3 watts. Yeah, I'm not really sure what that's about, why that would happen that way. But this is we're definitely on the MPS here. And we've gone into super duper low power. And if this is at all similar to what was going on before, this should take 3 times longer than what we saw initially. Matter of fact, let's go back here and see what we're getting. It's not showing us the output here. I guess it's going to show us the output here using Seaborn. It should draw the graph for us. Once this is done, we can run that. I know this is turning into a super long video, but I find it interesting, and I hope you find it interesting also. And I suppose that I can edit this so that you don't have to sit and wait for all of this to happen. It's all going to depend on how lazy I feel. I wish this was showing the progress. What we can look at here is the graph, but I don't see Anyway, this is the end of the whole paper, so this is, say, I guess this is minutes? So it looks as though the CPU took 10 minutes and this took 5. It was twice as fast. This does not seem to be running twice as fast. If anything, it seems to be running slower. And I have no idea why the power went, it just dropped so drastically. It's down to about 20 to 30% of what it was when it was operating on the CPU. Now I'm trying to see where the CPU started, and I'm not finding it. I did find where the MPS started here, which was here. Let me see if I can find that again. So what I'm looking for is those greater than signs that make up the prompt. Well, actually, that's... Alright, is there something going on here now? No, still doing its thing. I am curious about what's going on here. You can see this is 75% idle. It's barely grabbing any memory. It's grabbing 10 gigabytes for this. Barely using any energy. I don't think there's much disk I/O going on. looks like the only writing to disk that's going on is coming from the Streamlabs. No, that's not writing either. Yeah, there's not much disk activity. There should be no network activity at all. Well, it's certainly taking its time. Maybe it should use a little more power and get it done faster. Didn't take very long on the CPU. So we did the CPU test. It's unfortunate that I can't find the start of this. I don't think there's any way to be able to search through this. Alright, here it is. This is where the CPU started. And this is where we are. This is where we are with the MPU. We're down here. So it hasn't started any of this output yet. And so my guess is when this output starts, it's gonna fly by. So one of the things that we can look at here is why is GPU slow on M1 Mac or data science? Alright, well, I'm not having the experience of this going faster. It's going much slower. Uh, Now, I just hit enter, and I don't know if that was coincidental. that suddenly we're doing things again. So it may just be my stupidity. Yeah, it seems that we've got pages and pages and pages of this stuff. Looks as though it just flew by. Yeah. But as you can see, the power is back up. We're using a lot of memory, including 6.5 gigabytes of swap. And I don't know if that's included here in the RAM usage or if that's an addition, which would make this, 19 or 20 gigabytes altogether. This is giving the bandwidth. It's around 500 gigabits a second. Which is pretty fast. If it goes up to 32 gigabytes a second, if it goes up to 32 gigabytes a second, that means that all of memory can be rewritten twice every second. That's amazing. That's amazingly fast. Now it's got 4 E cores and 4 P cores. I don't know if that stands for economy and performance. Certainly, the P CPU's cores are getting much faster bandwidth. Look at this. This is getting 9 gigabytes a second. This is getting 2 gigabytes a second for the E cores. The GPU is getting even faster. All right, well, it's done here. Let's see what we can see. let's see, import. Oh, so we don't have Seaborn in here. So that's a problem. Let me fix that. And do a conda import Seaborn. Because we don't want to import it, we want to install it. And we want to make sure that we're in the correct virtual environment when we do this. And in my case, that's the M1 virtual environment. I had to switch into it. Alright, so let's do this. Let's do paste. No, we have lost our, let's go up to the clipboard here. And paste this. Well, maybe Seaborn has to be run within maybe it has to be run within the Jupyter notebook. I don't see that working. Anyway, this should give you some idea of how to get this all operating on an M1 Mac. And I thank you for joining me. If you have questions or anything, go ahead and put them down in the comments. And please like and subscribe and all that kind of stuff. Anyway, thank you once again for joining me, and bye-bye.